Hello and good day everyone. Welcome back to my YouTube channel. This is Sir Marcy and our lesson for today is all about combined variation. Let's try to transform this to mathematical equation. The speed s of a bicycle varies directly with the number of revolutions per minute r that you turn the pedals and with the number f of teeth on the front gear. This example is an example of joint variation. And if we transform this to mathematical equation, that is S is equal to KRF. Next one. Let's say we have the speed also varies inversely with the number B of teeth on the back gear. If you're going to examine, this one is an example of inverse variation. And if we will transform this to mathematical equation, this is S is equal to K all over B. Now, let's try to combine the two. If we combine these two equations, we will have S is equal to K RF all over B. And we read this as S varies directly as R and F and inversely as B. Or S varies jointly as R and F and inversely as B. We call this combined variation. Combined variation occurs when both direct and inverse variation together in a situation. And it is a variation where a quantity depends on two or more other quantities and varies directly with some of them and varies inversely with others. Now let's try to translate the following statement to mathematical equation. We'll use again K as the constant of variation. Number 1, the volume B of a gas varies directly as the temperature T and inversely as the pressure P. The answer here is capital V is equal to K, capital T all over capital P. Next number, let's say we are going to transform this to mathematical equation. The gravitational force G between two objects varies jointly as the mass of the first m sub 1 and the mass of the second m sub 2 and inversely as the square of the distance d between them. And the answer here is G is equal to K m sub 1 times m sub 2 all over d raised to the second power. Okay, let's have example number 3. Let's transform this to mathematical equation. The acceleration a of a moving object varies directly as the distance t it travels and inversely as the square of time t it travels. The equation here is capital A is equal to K, capital D all over t raised to the second power. Last example, capital W varies directly as C and the square of A and inversely as B. The answer here is capital W is equal to K A squared C all over B. In solving combined variation is the same step in solving direct, inverse, and joint variation. So the steps are as follows. Number 1, we have to write the correct equation. Combined variation problems are solved using combination of direct variation, which is y is equal to kx, inverse variation, that's y is equal to k all over x, and joint variation, y is equal to kxz equations. When dealing with word problems, you should consider variables other than x, y, and z. You should use variables that are relevant to the problem being solved. Also, read the problem carefully to determine if there are any other changes in the combined variation equations, such as squares, cubes, or square roots. Number 2, use the information given in the problem to find the value of k, or the constant of variation or constant of proportionality. Number 3, rewrite the equation from step 1 by substituting in the value of k found in step 2. And lastly, use the equation found in step 3 and the remaining information given in the problem to answer the questions asked. When solving word problems, remember to include units in your final answer. Right, let's try to solve example number 1. If z varies directly as x and inversely as y, and z equals 9 when x equals 6 and y equals 2. Find z when x equals 8 and y equals 12. So our step number 1 is to find the correct equation. So we simply translate this to mathematical equation. That is z is equal to k x all over y. Next is we're going to solve for k by plugging in these values. Z is 9, x is 6, when y is 2. So here, the value of z is 9 is equal to k multiplied to value of our x, which is 6, all over the value of our y, which is 2. So first, we have to cross multiply this. So 9 times 2, that's equal to 18, is equal to k all over 6. Then we divide both sides of the equation by 6. Then k now is equal to 3. So 18 divided by 6 is 3. Alternatively, notice that 6 and 2 here are also, we can also simplify this. So 6 divided by 2, that is equal to 3. Okay? So I'll just show you the other solution. So 9 is equal to k multiplied to 3. Then we divide both sides of the equation by 3. Then we have the same answer. K is 9 all over 3, which is equal to 3. Okay? So that's an alternative way of finding the value of k. Next is, after we solve for k, we will plug in this to our equation. So from z is equal to kx all over y, we now have our equation of variation, which is z is equal to 3x all over y. Now from this, we can now solve the remaining information. So we're going to solve for z when x is 8 and y is 12. So that is z is equal to 3 multiplied to 8 all over y, which is 12. So we know that 3 times 8 is 24 divided by 12. And when you divide 24 by 12, the answer is 2. So therefore, the value of z is equal to 2 when x is equal to 8 and y is equal to 12. Okay, this will be our last example. Example number 2. Y varies jointly as a and b and inversely as the square root of c. If y equals 12 when a equals 3, b equals 2, and c equals 25. Find y when a equals 5, b equals 3, and c is equal to 9. So again, our step number 1 is we find the correct equation. That is y is equal to k AB all over square root of C. Next is we need to solve for K by plugging in these values. So Y is equal to 12 is equal to K times the value of A, which is 3, and the value of our B, which is 2, all over the square root of C, which is 25. Now, we simplify first the equation. This is 12 is equal to k multiplied to 3 times 2, which is 6, all over square root of 25, that is 5. Next is, we simply multiply this to solve for k. That is now 60 is equal to k times 6. Then, we divide both sides of the equation by 6. Our k now is equal to 60 all over 6, or that is equal to 10. So our k is 10. Next is we write the equation of variation by plugging in the value of our k, which is now 10. So y is equal to 10 ab all over square root of c. Then we can now solve for the remaining information. Find y when a equals 5. So y is equal to 10 times 5 times b, which is equal to 3, all over square root of 9. So notice that if we simplify square root of 9, we have y is equal to 10 times 5 times 3 all over 3. Then we can cancel this out. What is left is 10 times 5. The value of y here is 10 times 5, and that is equal to 50. That's all for now. Thank you for watching, and please don't forget to like and subscribe to my YouTube channel.